Okay, hello guys, how are you? Now let's talk a little bit about the average memory access time in operating systems. So, as the name suggests, we are talking of the formula for an average value for how much time it takes for me to get to the memory. And we'll talk about the cache and the RAM, how much time it will take from the time I am the CPU that gives me the request for memory until I get the data from the memory. Now, the fastest way is if the CPU can get his data from the L1 cache, is the fastest, is the closest, gives me the fastest way to get the data, but it's quite small. So there might be a miss, namely the data is not in the L1 cache, it will be maybe in the L2. It can also not be in the L2 or L3, and if not, we will need to go to the main memory, to the RAM. And this is the slowest. Now, the question is, what is the average time? Now, it depends on what is the hit rate for each one of them. See what is the probabilities that the data will be there if I'm going and to this level, and what is the hit time for each cache. You see that as the level rise, the hit time is suggested longer. And of course, for the main memory, you can see that the access time is much longer. So there is a formula. The average memory access time is built from the heat of L1, which in this example, it's zero point 0.5 nanoseconds plus 1 minus the heat rate for L1. The probability right over here, I can change it, but for this example, it's 9%. Times all this, what there is, you can see the values 0.5 from here, and 1 minus 90% is 10%. Now all this multiplied by L2 heat. L2 heat is 4 nanoseconds. So here you see the 4 nanoseconds plus 1 minus the heat probability, heat rate. So it will be 5% plus uh, multiplied by L3 heat, which is 15 nanoseconds, plus y1 minus the heat rate of L3 times the memory access time, which is 100 nanoseconds. This is the formula for average memory access time. This is the expected average memory access time from the formula, which will be as, let's see the animation. You see how it calculates for me what is the average that is running. He calculates what is the average and running an examples again and again based on the percentage, what is the percentage to be here or the data to be here based on what the CPU requests. And you see that the value right over here should, with the time, comes to around the value of the formula. You can see it moves and everything. You see how it changes. Sometimes only to L1, which is 9%, L2, 3, and maybe to the even the main memory. And this value should get to the expected formula value. But you see, it's not, it takes time. Anyway, this is the idea of average memory access time and its formula. And thank you very much. If there are any mistakes or corrections, please tell me. Thank you very much, and that's it for now.